Okay, I wanted to today go over the study guide for Test 5 over lessons 18 through 20. In case you have not taken Test 5 yet, I wanted to help prepare you for it. So I'm going over the questions from the study guide. I won't go over every single question, but I'll go over a good majority of them today. Question 1. The first derivative of a continuous function y equal f of x is given. Find y double prime, that means find the second derivative, and then sketch the general shape of the graph of f. All right, the second derivative, the derivative of 12, that's a constant, so that would be 0. The derivative of 1x is just 1. Excuse me. And the derivative of negative x squared is negative 2x, using the power rule for derivatives. So we got the second derivative, no problem. Now we need to choose the correct sketch of the general shape of the graph of f. This is where antiderivatives come in. Antiderivative, excuse me, means that you are taking the power rule and working it backwards or reverse. So looking at our original first derivative, that 12 is understood to be 12 x to the 0 power. And instead of subtracting 1 from the original exponent and moving your original exponent to the front of the term, we're going to do the reciprocals. So for 12x to the 0 power, instead of subtracting 1 from the original exponent, we are going to add 1 to it. Instead of multiplying, we're dividing now by our new exponent. The same thing with the second term, x to the first power. Again, to take the antiderivative, you add 1 to the original exponent. And instead of multiplying, you're dividing now by the new exponent. For the negative x squared, do the same thing. Add 1 to the original exponent. And divide your antiderivative by your new exponent. So that gives us 12x to the first power over 1, or just 12x, plus x squared over 2, minus x cubed over 3. And normally you would put a plus c to represent any possible constant, but we don't need that here. We're just looking at what the original function f was. Look at the highest exponent, and that tells you the behavior of the original function. We know x cubed looks like a roller coaster, and the negative part means that it's going in reverse or inverted order. So the graph that looks like that is B. right away you would eliminate choice C because that is a parabola, and we know a parabola has the highest exponent of 2. All right, next question. Pretty much we're doing the same thing, except this one involves a trig function. So let's find the second derivative. And the second derivative, or the derivative of sine x, or 2 sine x, is 2 cosine x. So that's the second derivative, or y double prime. Now, if we go backwards, right here at our original first derivative, and we take the antiderivative, and you'll learn this later, the antiderivative of sine is actually negative cosine. So this will be negative 2 cosine x plus some constant. Now, the regular cosine curve behaves this way. But since we have a negative sign, a negative number, then it's going to be inverted. So the correct graph of the original function is A. Let's look at question 5. This question does not really involve any work. All you have to do is use the graph to answer the question. So let me move it over so we can see it. The accompanying graph shows the hypothetical cost C equal f of x of manufacturing X items. At approximately what production level does the marginal cost change from decreasing to increasing? So let me enlarge our graph. So the point where the marginal cost changes from decreasing to increasing, that would be where, well, a couple of indicators. Where your graph changes concavity, that is an indicator. And concavity means going from concave down or cup down. And concave up is just a regular parabola with the cup right side up. So where that happens is about roughly 60,000 units. So we had to use the inflection point to determine the point where the marginal cost is changing from decreasing to increasing. Okay, the next question is a word problem. Find the smallest perimeter and the dimensions for a rectangle with an area of 81 square inches. We're given both perimeter and area, so we need those two formulas for a rectangle. So area is equal to length times width, or x times y. And the formula for perimeter for a rectangle is 2 times the length, or 2x, plus 2 times the width, or 2y. Now we need to get one formula in terms of just one letter so we can take the derivative. The only other information we're given is the area is 81. Now you can either solve for x or y with the area formula. It does not matter. You'll end up with the same perimeter and dimensions. I'm going to divide both sides by x. So y is equal to 81 over x, or 81 x to the negative 1 power. Now that's what we're going to plug into y in our perimeter formula. So we have 2x plus 2 times 81 x to the negative 1 power. Now, before we find the first derivative, let's multiply 81 and 2 together. That will be 162 x to the negative 1 power. Now we're ready to take the first derivative. How I know to take the first derivative is the keyword smallest. If you have keywords like smallest, least, greatest, most, then that means you're trying to find relative extrema, max or min points. So when we take the first derivative, we get 2. And using the traditional power rule, we get negative 162 x to the negative 2 power. And all I did there was move the original exponent to the front and multiplied it by 162, and then subtracted 1 from the original exponent. Now, our next step is to find what's called the critical value or values. There may be more than one. And to find that, or those, you set your first derivative equal to 0. So up here we have 0 equal to 2 minus, and let's rewrite that negative exponent back to a positive one. That would be 162 over x squared. And I'm just moving that fraction to the left side. And just solving for x at this point. I'm going to multiply both sides by x squared to get rid of that fraction. And that leaves us with 162 equal to 2x squared. And let's divide both sides by 2. We now have 81 equal to x squared. To solve for x, you know to take the square root of both sides. So that would give us x. Now, normally when you take the square root of a positive number, you get two different answers. Here, a positive and a negative 9. But you reject the negative 9 because we can't have negative dimensions. So x is equal to positive 9. We need to find the other side, whether that's the length or the width. I'm using this equation over here. 81 over x equal to y. To find the other side of our rectangle, just plug in 9 for x. Therefore, our other side is also 9. The last thing we need to find is the perimeter. So go back to your perimeter formula. And replace both x and y with 9. Therefore, our smallest perimeter is 36. Again, right here, remember to only accept the positive answer because dimensions, as you know, cannot be negative. Next question. And hang on just a second. A rectangular plot of farmland will be bounded on one side by a river and on the other three sides by a single strand electric fence. With 2,400 meters of wire at your disposal, what is the largest area you can enclose and what are its dimensions? Tell you what, let me copy and paste this to our whiteboard so we can work it out. And I'll copy the answers too. All right, let's see what we're given. We're given a rectangular plot of farmland is bounded on one side by a river. Okay, so here's our river. And here's our farmland. Let x equal to our width and y equal to the length. Again, we are given two things, perimeter and area, so we need two formulas. Area equal to length times width, or x times y, or y times x, if you want to switch them around. Now, our perimeter formula is not the standard formula for a rectangle, because one of the sides of our farmland is bounded already by the river. So we just need these three sides. So x plus x is 2x plus the one length up there that's not bounded by the river. The other information we're given is the perimeter is 2,400 meters. Now, before we find the first derivative, we need our area formula to be all the same letter, since we're trying to find the largest area. So with the perimeter formula, you can solve for x or y, it does not matter. Since y has a coefficient of 1, I think it's the easiest one to solve. So subtract 2x from both sides. And we get 2,400 minus 2x equal to y. Take that expression and replace the y with it in your area formula. So we now have x times 2,400 minus 2x again, we have keywords like maximum and largest, so that means we need to find our first derivative and also critical point or points. But before we find the first derivative, we have to distribute that x. And I'm actually going to rewrite the terms after I distribute the x. So x times 2,400 is 2,400x. And x times negative 2x is negative 2x squared. We're ready to find the first derivative. So a prime is equal to negative 4x plus 2,400. And don't forget to add your x there. I've left it off by mistake. Now, to find our critical point, set your derivative equal to 0. We have 0 equal to negative 4x plus 2,400. And when we divide both sides by 4, we get 600 meters. 600 meters is the width. To find the length of the longer side, or y, just use this formula right here, or equation, sorry. And replace your x with 600. And that gives us 2,400 minus 1,200. So the longer side is 1,200 meters. We found the shorter side, the longer side. Last thing to find is the maximum area. So just multiply your length and width together. So that would be 1200 times 600. So the maximum area you can enclose is 720,000 square meters. Bottom line, you may have to modify a traditional formula like we did for the perimeter. All right, let's look at the next problem. And let me screenshot it to our whiteboard. Just a moment. Two sides of a triangle are 14 and 7, respectively. Find the size of the angle theta in radians formed by the sides that will maximize the area of the triangle. There's an unconventional formula that we have to use, not the standard base times height. It is area equal to 1/2 A times B times sine theta, where A and B are the given sides. So again, we have to take the first derivative. Keyword that lets us know that is maximize. But before we find the first derivative, let's plug in our sides. When you simplify the numbers, 2 can go into 14 7 times, and 7 times 7 gives us 49. We're ready to take the first derivative. So A prime is equal to 49 cosine theta. You still need to find your critical point or points because we're trying to find, informally, we're trying to find x like we've done before. So set your first derivative equal to 0. And we'll divide both sides by 49. Now, to find theta, you just simply ask yourself, where on your where on your unit circle is cosine 0? Well, cosine is the x value. And cosine is 0 at 2 places, at 90 degrees or pi over 2, and also 3 pi over 2 or 270 degrees. Now, because our two sides are, well, they're positive, of course, that's a given. Inverse cosine theta has a restricted domain. And let me show you what that domain is. in the view and example, okay, that doesn't tell me anything, I'm sorry. But you would only accept the first answer, the pi over 2. Let me look up the restrictions for inverse cosine. Hang on just a second. Domain for inverse cosine. Okay, so the domain is from -1 to 1, and the range is from 0 to pi. So pi over 2 is the only answer, only angle that's in our range. So that's why we did not choose or include 3 pi over 2. Question 9. Find the antiderivative for each function when c equals to 0. So if c is equal to 0, then you do not have to put plus c. Do as many of these as you can mentally. I'm still going to show you or review with you how to take the antiderivative. The antiderivative, let's start with question A. Traditional power rule, you would move the 7 to the front and multiply it by the 8, and then subtract 1 from the original exponent. The opposite, we're doing opposites here to find the antiderivative. So instead of subtracting 1 from the original exponent, we are adding 1 to it. And instead of multiplying, the opposite of multiplication is division. So we're dividing our antiderivative by the new exponent. And that gives us 8x to the 8th power all over 8. And the 8's cancel. So our antiderivative is x to the 8th power. Let's look at question B. Again, to take the antiderivative, you add 1 to the original exponent. And instead of multiplying, the opposite of multiplication is division. So you'll divide your antiderivative by the new exponent. And this gives us a final answer of x to the 6th power over 6. Or 1 over 6 times x to the 6 is correct too. Part C. Find the antiderivative of x squared minus 6x to the 1st power minus 7x. I'm going to rewrite that minus 7 as minus 7x to the 0 power because we know x to the 0 power is 1. For each term, to take the antiderivative, you first add 1 to the each original exponent. And you divide each antiderivative by your new exponent. So 2 plus 1, 1 plus 1, and 0 plus 1. First term's antiderivative would be x cubed over 3. Second term's antiderivative would be 6x squared over 2. But 2 can go into 6 3 times, giving us negative 3x squared. And the last antiderivative is negative 7x to the first power all over 1. And that's just negative 7x. Now, if you did not have the stipulation that c is equal to 0, then you must put a plus c after each answer to cover any possible constant. Question 10, let's look at these. Find the antiderivative for each function when c equals 0. Now, these are slightly different only because we need to rewrite each fraction with negative exponents. So we can do part B. Rewriting part B as a negative exponent gives us 5x to the negative 7 power. To find the antiderivative, you first add 1 to the original exponent. And you divide your antiderivative by your new exponent. So our final answer is negative 5x to the negative 6 power over negative 6. Sorry, I have an extra negative there. The last thing to do is rewrite our negative exponent back as a positive 1. So we'll take the x to the negative 6 power and move it to the bottom. So negative 5 over 6x to the 6 power is correct. You would actually do the same thing for questions A and C with the fractions. Question 11, if you see one like this on test 5, you can write down a wrong answer or skip it altogether. I haven't talked about indefinite integrals as of the time I'm making this video. Same thing with 12. And actually 13 and 14, you can either write down, when you see these questions on test 5, they may be mixed up, but when you see them on test 5, you can either write down wrong answers or skip them altogether, and I will go back and give you full credit, only because I have not talked about indefinite integrals at the time this video was made.